Okay, so for this time, we're going to investigate or determine the strength capacity ng ating T-beam for flexure. So ito na ngayon yung na-design natin na T-beam. As you can see here in this picture. So ito yung solution. So first, i-determine muna natin yung effective depth ng ating beam. So para direct na natin ma-solve, total single layer lang naman yung ating steel reinforcement dito. So itong 600 na each, babawasan na lang natin ng steel covering na clear concrete cover plus diameter ng ating stirrups plus yung bar diameter na 25 divided by 2. So yung masasolve natin na effective depth is 537.5. Pero sakali na merong second layer, then you are going to make use of the Varignon's theorem talaga para masolve nyo yung effective depth. After that, we're going to compare it sa ating minimum na steel area. So, I think nasolve na natin to previously. So, ulitin na lang natin. We have 0.25 times the square root of FC prime na 28 divided by yung FY natin 420 times 300 times yung D na 537.5. We have 507. So, this is 507. Then, compare natin naman ito sa 1.4 all over Fy na 420 times yung B sub W na 300 times 537.5. So we have 537.5. So the maximum value is 537.5. Ito na ngayon yung mag-govern na minimum steel area. So compare lang natin to sa ating A sub S. Kasi di ba we have 4 rebars times pi times 25 squared all over 4. That is equivalent to 1963. Ito na ngayon yung provided na steel area. Since yung provided na steel area natin is greater sa minimum, therefore okay. So tama yung pag-design. So after that, we're going to solve for the area ng ating concrete block. So meron na tayong 1960.4954. 1960.4954 times yung ating Fy na 420 divided by yung 0.85 times yung ating FC prime na 28. So yung makalculate natin na area ng ating concrete block is 34,649.919. And the area ng ating concrete flange is 182,500. That is equivalent to 1825. Yung nasolve natin previously from our design times yung H sub F natin na 100. So after that is since yung A sub C or area ng compression block natin is less than siya sa area ng ating concrete flange. Therefore, this is not trial. Masusog natin yung depth ng ating compression block. So, bale yung illustration nito or diagram na i-consider natin is ito siya. So, para masolve natin yung A, yung area ng ating compression block is equivalent to BF times yung ating A. So, masasolve natin yung depth ng compression block after. So, yung area ng compression block natin na 34,649.919, weight natin ito sa A times yung BF na 1,825. So we'll get here a value of 18.9863. Okay. After that is to solve for our beta factor. Since yung FC prime natin is 28, therefore, 0.85 yung magiging value ng ating beta factor. After that is yung location ng ating neutral axis. So, A lang 1 over beta. We have 18.9863 divided by yung beta factor natin na 0.85. So, we'll get 22.3368. After that is to solve for the yield strain ng ating steel reinforcement. So, Fy natin na 420. Di-divide na lang natin to sa elastic modulus ng steel na 200,000. We'll get 0.0021. After nito is to solve for the strain ng ating tension steel. So, 0.003 times yung D na 537.5 minus yung C, which is 22.3368 divided by 22.3368. So we'll get 0.06919037. Since this is greater than 0.005, therefore tension controlled. If that will be the case, yung stress reduction factor natin is equivalent to 0.9. After nito is check for ductility requirement. So again, yung strain ng tension steel natin is greater also than 0.004, meaning ductile yung ating beam. So therefore, okay. Then, greater din ito sa ating yield strain. So meaning, tama yung ating assumption that yung Fs is equivalent to Fy for our tension steel. Meaning, tension steel yields, correct assumption. After nito, is to solve for the centroid ng ating compression block. Since yung A sub C natin is less than A sub F, therefore, masosolve natin yung ating Y, which is equivalent to A all over 2. So, yung A natin na nasolve kanina is 18.9863 divided by 2, we'll get 9.49. At 9.4931. After that is to solve for our moment arm. So D lang minus Y. So 537.5 minus yung ating Y, which is 9.4931. So we'll get 528.0069. And after nito, is masosolve na rin natin yung ating nominal moment strength. Ito going to sum up our moment doon sa centroid ng compression block ng ating compression block stress. So, yung A sub S natin, which is yung value ng A sub S, 1963.4954 times Fy na 420 times yung Z natin na 528.0069. Divide na lang natin to sa 10 to the power of 6. We'll get our nominal moment strength to be equivalent to 435.4304. Then, if we're going to multiply it by the strength reduction factor na 0.9, masosolve natin ngayon yung ating pi mn. So, 0.9 times 435.4304, you'll get 391.874. If we're going to compare it dun sa ating factored moment na 348 lang, so yung capacity is greater than our demand. Therefore, safe yung ating beam, P-beam for flexure.